Hello everybody. We will be learning about the solar power sizing in this module. So just to recap our previous module, we learned about the solar power design and outlook. So how does the solar power system gets designed? What are the different kinds of balance of systems which are used in solar power design? So before taking us a session, let's talk about our organization called Neutrino Energy Private Limited. We are a multidisciplinary organization which provides renewable energy capacity building, CSR advisory and implementation, renewable energy services. We have been recognized and acknowledged across the world with the common purpose of sustainable energy for all. We have only one motto in mind: go renewables. Your neighbors will think you did it for environment, but you know that you did it to save money. Some of the awards and recognitions that we have concluded is listed below: Harvard University Young Leaders Debate, Nudge Global Leadership Challenge, Climate Reality Project, Ministry of Gender Equality and Youth Affairs, Waka Waka, the Solar Power Initiative, one of the greatest initiative that is running in West Africa. Talking about the solar power sizing, I'll be taking the example of your home. Let's imagine that you have the CFL light bulbs of 9 watts which runs almost around 5 hours in a day, and you have two numbers of that CFL. You have one fan which is of 60 watt and which runs almost around 8 hours per day. You have a TV of 21 inch of 150 watt, it's their rating, runs almost 2 hours per day and it's in one number. You have the refrigerator 150 watts, it almost runs 8 hours in a day and you have one numbers of it. You have the computer of 1 numbers which runs almost 3 hours in a day and which is of 250 watt. So how watt hour is getting calculated here? So watt hour is nothing but watt into hours, like such as 9 watts, hours per day and into numbers. So 9 into 5 which is 45, 45 into 2 is like 90. So same has been repeated for all other appliances. So if you talk about your energy requirements, which is like 2820 watt hour, if you want to convert into kilowatt hour, which will be like, I'll be dividing it by 1000 and it will be like 2.820 kilowatt hours, like 2.82 units, which is approximately 3 units in a day. So this is all about your load requirement. Let's talk about more about how solar system looks like. So as we have already described in our previous module, these are the 4 components. So this is our load which you're gonna power up through solar PV modules and battery, and inverter is used normally for converting DC to AC. So first we'll look about your load requirements, how it is getting estimated. So in this tape, one needs to know how much energy is getting consumed at your end. So what is the kind of energy load requirement from the appliances end? So energy consumed by the load is obtained by simply multiplying, which we have already done, power rating into number of hours of operation. And our example which we concluded, our total energy consumption was almost around 2820 watt hour. This is the AC power, right? Now the PV system must be designed in worst case scenario, because there are lots of losses which will be happening from inverter end to battery end, then battery end to the load end, and then solar energy power panel end to battery end. So hence we need to oversize our system to cater out this kind of requirement in a very easily manner. So we need to, hence the required load is, how the energy is getting supplied. It is supplied from the panel to battery, panel to inverter, which is again in parallel, because normally battery requires DC voltage at DC current, and inverter which is normally used to convert DC into AC. So normally it is, how does it flows? It flows from solar panels to DC battery, DC battery to inverter, inverter to load. Now we need to consider all the losses in order to design an optimal system. Hence the inverter should be able to handle the current to be taken from the battery. And normally input voltage ranges from 12 volts to 72 volts and the currents from 1 ampere to several of tens of ampere. The output voltage of inverter would be 220 volt AC at 50 Hz, which will be normally the same rating which is used by your appliances. and in our example the total load connected to the inverter is 628 watt. Now how it have been calculated? The rating of the devices and number of devices. If you calculate, and summation of all would be 620 watt here. Now the daily energy used is like 2820 watt hours, but we need to cater out the, as I told you, efficiency of inverter. It's almost 90%, but we will consider as 97% as a highest efficiency. Hence, with the moderate efficiency we will consider for our calculation is 93%. Hence, the total energy consumption would be this much energy efficiency that we need to consider for inverter. Hence, the total energy to be consumed will be 3032. So this is the optimal load estimation that we need to consider at this point of time. The voltage and current in the PV system after the inverter is AC, but before the inverter the voltage and current will be of course DC. And the input voltage to the inverter will depend upon the battery voltage, line current, voltage drop, power losses in the cables, that also we need to consider, because these are the important parameters for designing or sizing a system. The battery voltage would be almost 12 volt, hence the PV system voltage also be 12 volt or in the multiples of 12 volt, because ultimately the 12 volt which we need to supply to the battery. Hence we also need to categorize the optimum PV system voltage in order to minimize the power losses and voltage drop in the cables. Now in order to obtain higher system voltage we need to put in more batteries and PV panels. Hence in order to obtain 24 voltage we need to cater out two 12 voltage batteries to be put in series. So this is the kind of multiplication in the numbers of 12. Again it will be same applicable in case of panel which will be connected in series to generate enough voltage for getting the terminal voltage of 24 volt. Hence one needs to optimize between power loss and system voltage. For our example, let us consider 24 volt as a system voltage. Now we will be generating energy at 24 volt, and which will be same supplied to the battery at 24, same supplied to the inverter at 24 volt. So now we have calculated the load estimation. So now let's talk about how to size the battery. Sizing of battery. We have estimated our normal energy consumption is 3032.25 watt hours at 24 volt. Now parameter to be considered for the depth of the batteries would be depth of discharge, like what is the discharge capacity of the battery, like what is the usable capacity of the battery. Then voltage and ampere hour, that is normally battery is getting rated into the ampere hour, that is the unit of battery. Number of days of autonomy, like if suppose you are charging a battery for 1 day and how many days you want to use that battery, like how many days you want to consume the energy from that battery. So that is one of the important parameter. So I already told you, like depth of discharge, which normally takes into the range of 60 to 80%, but in our case we would be considering 70% as an average, and we would be considering 12 volt 100 ampere hours capacity. This means that if my depth of discharge is 70%, 70% of 100 ampere hours, which is like 70 ampere hours, which is only the usable capacity that you can use and that you can consume the energy from it. Hence the total watt hour that we need to use is, we need to consume is like 3032.25 hours, and the total voltage that we need is 24 volts. So hence the battery capacity would be 126.3 hours ampere hours, but our usable capacity is only 70 ampere hours, which is like 100 ampere hours into depth of discharge, like 70%. Hence we need to divide that in order to get the number of batteries. Now the number of batteries would be like 1.8 numbers, because this is the total number of capacity that we need. This is the rating of battery which is available with along with the depth of discharge, and number of batteries will be 1.8. We need, if we would need to round up this number, it will be like 2 batteries of 12 volt. But what is the system voltage that we need? We need 24 volt as a system voltage, but we are only 12 volts. So what we're gonna do is we're gonna put the 2 batteries in series to generate a 24 volt. Hence again, but we need 2 batteries. So in order to generate 24 volt 2 times, we need 2 again the extra batteries of 12 volts. So hence the total number of batteries would be 4 because we are connected to 12 volt batteries in series to get 24 voltage as terminal voltage. Hence the total will be 4 batteries of 100 amperes. 2 of them will be connected in series. 2 such a series connected in batteries are connected in parallel. Hence there would be 4 batteries. Now another concept that we need have already discussed, autonomy. For how many days you want to consume the energy from the batteries. Now how we normally calculate the number of days of autonomy, and it depends only and it normally get impacted upon the battery rating. So AH, total AH capacity, how it gonna calculate? X, the current capacity, N, the total number of autonomy days that you want. X is like the current capacity. So we have the current capacity is like 126.3. 2 is the number of days we wanted to have the autonomy, and again the battery rating at this point of time. The revised battery rating with 2 days of autonomy will be like 378.9. Again the same thing, that we need to calculate out the number of batteries, like 100 amperes hour, that is the battery rating, 0.70, 70% is the rate of discharge. Hence the total number of batteries would be 5.4, which is approximately 6 numbers. Now it is getting 12 volts, but we need 24 volts. Hence we need 6 number of batteries to be connected at one series as a 12 volts. It will generate a 12 volt. We need another series which can capable of generating 24 volt. So we need 2 such a series in parallel. So one series of 6 batteries, one series of 6 batteries, getting 2 series, total batteries would be 12. So these are the 12 volt batteries and 100 ampere hours capacity. So this is how the battery gets sized. So as the number of autonomy days increases, of course the battery's bank size will increases, and the higher autonomy is required, PV systems will require again higher reliability. Now if you want to reduce the cost of system, normally you have to use the autonomy should be 0, and almost the battery cost will almost around 30% of the total system cost. So this is all about the battery sizing. We talked about the load estimation, we talked about the battery, but now we need to talk about the solar PV modules. How we gonna rate the solar PV modules? Let's talk about solar PV modules. Now the parameters of PV module sizing will be like voltage, current and wattage of the module that needs to be required, solar radiation at a given location and at a given time, which we have already considered in our first session, how the solar radiation in India, efficiency of the batteries, temperature of the module, efficiency of maximum power point tracker and charge controller unit, dust level in the working environment. So these are the various kind of parameters. The PV panels are required to supply the energy to the battery, which is consumed daily, but the total energy will be stored in the battery bank in order to use for the high-end applications. So as we already considered, our total energy supplied by battery bank would be 3032.25 watt hours, but the energy supplied to the input terminal of battery bank from PV should be higher, because we need to consider also the battery efficiency in place. Normally we will consider the battery efficiency will be 80 to 90%. Let's talk about battery efficiency is like 85%. So we also need to cater out that thing into mind, and hence the total new energy supplied will be like 303.32.25 divided by 85%, which will be like 3567.3 watt hours. So normally input terminal of battery, which will be connected to the controller, charge controller, which will be normally another device to take the control of battery charge capacity and discharge capacity. If you take the controller circuit efficiency at 90%, again we need to divide by 90% with a new energy supplied. Hence the new energy supplied would be 3963.7 watt hours. We are considering the 24 volt as a battery capacity. Hence in order to calculate the total ampere hours, what is the kind of ampere hours that PV panel should carry? So that will be like 3963.7 watt hours, like V into I into hours, and if you divide by 24 volt, it will be like 165.1 ampere hours. And normally I am considering the daily sunshine hours of almost around 1 kilowatt, that is 1000 watt per meter square, that will vary between 5 hours and 7 hours. And if I take an average, I'll consider it 7 hours of equivalent peak sunshine hours, like 6 hours, like in 24 hours you will get sun rays for at least 6 hours. So we have the 165.1 ampere hours of a capacity that solar PV panel should carry. Now I want to calculate the current rating, how much current my solar PV panel should generate. So if I divide by 6 hours, this hour in the ampere hour will get removed. So 165.1 divided by 6, which will be like 27.5 ampere. So solar power should generate 27.5 amperes of capacity. Let us consider the 75 watt modules for an instant. Now if we consider the 75 watt panels, it would have 50 volt as a voltage and 5 ampere as a current, but we need 27.5 ampere current. So 27.5 divided by 5, that will be like almost 5.5, but if we like get into the round off, it will be like 6 modules. But again, we need that 6 modules at 24 volt, but what is our voltage? 15 volt. Hence we need to connect this kind of a 6 PV modules in parallel, but we need to put that 2 modules in series because we need 24 volt and the current generation capacity at 15 volt. Hence if we put these 6 modules in a series, one series, 6 modules in another series, and again this 6 bunch of modules in parallel, there will be 12 modules which will be required of 75 watt peak. So this is all about the sizing of PV modules. Let's talk about the sizing of inverters, how inverter gets rated. Most our inverter are like the rating will be available in kVA, that is kilovolt amperes, or VA, like volt amperes. In ideal situation, 1 volt ampere is 1 watt, wherein we are considering the power factor, like where watt, like active power. Watt is nothing but an active power, which is like V into I into cos phi. Cos phi is power factor. When the cos phi power factor is 1, the VI is VI, like VA is watt, 1 VA is 1 watt. But in real situation, power factor varies from 0.85 to 0.99. But if I want to assume that 1.18 VA is 1 VA, so if I want to set up a 1 watt of a or 1000 watt of a solar system, I want to take up an inverter of 1180 VA, that is 1.18 kVA. In our system, we have the 75 watt modules, 12 numbers of panels. So total system of solar will be like 900 watts. In order to get into the rating of an inverter, I need to multiply it by 0.18 or 1.18 in a percentage manner. So 900 into 1.18 will be like 1.062 kVA. This is the inverter rating that we need to carry out. And this includes all the losses and other things, because we have already considered the all losses in the system. So this is all about the sizing of inverters. So we have considered load estimation, so we have considered solar panels, we have considered batteries, we have considered inverters. Now let's take a summary of all the overall system. Solar PV modules, 12 numbers of 75 watt, batteries 12 numbers of 100 amperes, and inverters 1 numbers of 1.062 kVA. This will be required to generate an energy which is of almost 2.820 kilowatt hours or 2820 watt hours. So it will generate 2.82 units in a day to supply your electrical appliances. So this is all about the solar sizing and solar rating for all the balance of systems. This is our module 3. In the next module, we will be looking after what are the different kinds of policies and regulatory scenario that currently in place in order to boost up this kind of a solar energy capacity in a country, which is like more into the managerial level. So till then, goodbye. Thank you.